Hi, and welcome back. Um, on the last video, we were on the topic 2.4.5, which is about how to represent a rigid body in a space. And we finished the last video uh, solving the example 2.5, how you can which is how you can find the missing elements from the matrix which represent a referential. It was this matrix which represent a referential, and using this referential from this system of axes and A O, we can write a vector in a space based uh, on this referential system. And as a rigid body, it has 6 degrees of freedom, but on the matrix that represent our referential, it has 12 elements. Because of this, we need to write 6 restriction equations for this rigid body. And doing this, we can find the missing elements, which represent position, orientation, or if our body is doing a rotation movement or translation movement. So we solve these equations, and on this video, uh, we will talking about homogeneous transformation matrices. So which is what we are about to discuss right now. So let's dive into it. This topic is very short and briefly introduce the concept of uh, square matrices and tell to us the reason why is interesting for us to maintain the matrices in the quadratic form. And further, um, we will see the topic 2.6, and we will explain more about the term transformation, which in our context is referred to transformation in a position, transformation on the orientation, if the rigid body is doing a rotational movement. So the matrix is the form that we represent those movements of a rigid body on a space. Okay, homogeneous. So let me drag this, drag down. Sorry, let me scroll down. Okay, first I'm gonna read what is being presented. So it says that for many reasons, it's desirable to maintain the matrices on the quadratic form, whether 3 by 3, whether 4 by 4, and if you remember from your classes, we on a matrix we have the columns and we have the rows. So that is the term of a matrix A1, A11, and that means the first 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 row, and the second number it means the first column. So on a 3 by 3 matrix we have in a total 9 elements. So on this row we're going to have the element 1, A12, A13, and that the row, and that is the column to 1, A to 2, A to 3, A 3, 1, which is the third row and the first column, A 3, 2, and A 3, 3. And quadratic, it means that the number of rows is the same of number of columns. So as you can see right here on this matrix 3 by 3, we have 3 columns and 3 rows. So that what categorizes a quadratic matrix. And as I was reading to you, the book presents to us that is interested for us to maintain the matrices on the quadratic form because of some reasons. First, is easy, is more easy to calculate, the inverse of quadratic matrices. Then rectangular matrices. Second reason, in order to multiply in order to multiply two matrices, your dimensions, it has to be equal. Their dimensions, their dimensions need to be equal. And that means that the number of rows needs to be equal to the number of columns. So as we were seeing right here, the element. Let's do it again. Another example. Let's see this. this element A 3 2. 3 is the number of the row, and the second number is the number of the column. So in order to multiply two matrices, the number of rows it needs to be equal. It has to be equal to the number of columns. Okay. And as I said on the middle of this video, because I'm gonna start the topic 2.6 in other video, this topic 2.5 is very short, and we are already on the end. And it says in order to maintain the matrices on the square form, quadratic form, if we represent both orientation and the position on the same matrix, we will add the scale factor W on the matrix. So this matrix, it will be will turn in a matrix 4 by 4 this way. Px, Py, Pz, and this row it has the scale factor W, and basically this topic is bringing to us this information. It is kind of an introduction to, so we can start talking about the type of transformation that we can apply on the rigid body. And that's it. And on the next video we will start to solve this example, which is about a referential that are being moved 10 units alongside the axis y and 5 units alongside the axis z on this reference system. Okay, and that's all for now. Thank you, and follow along, and see you on the next video. Bye bye.